Python, when you think about it, all these years, what most people do is, they press the Windows key, find Notepad or a different, program, open up Notepad. And this is the interesting part, right? They start typing away, or they go File Open or Control O or whatever, to get to whatever file you need. But there's a lot that goes on that people don't think about. You have to allocate memory space to Notepad itself. Notepad has to allocate memory space to the file that you're opening. And if the file doesn't exist, it'll give you the opportunity to save it and create it. If you need to reopen it, you can reopen it, append it. But working with this GUI, it's kind of cumbersome. But everybody is so used to it because the past 30 years, this is the way, right? But prior to that, it was all GUI driven, using VI or different types of Notepad-like programs, but it was all done command line. And once you learn how to master working with files via command line, working with databases, APIs, program interfaces, storing data, opening files, gathering logs that you need, or gathering data you need, or finding certain information, it becomes a lot faster, like exponentially faster. For an example, like I can parse through 2 billion log events from the DNS in less than a minute. That's on a desktop. That's not taking it to a server with some power. That's just some scripting and having a raw file and ripping through it and looking for matches, pattern matching. So there's a lot to be said with how to work with files. I'm going to rearrange the screen here in a different way, though. So I'm going to open up this guy right here, too, because I actually want to show you the creation of the files and how long it takes and all that fun stuff, right? Let me just get situated. We'll take off here. So here's lesson 7. I'll put this right here. Make it nice and small. Does it do that? No, it doesn't. No, it goes. Only on your main screen allows you to do it all crazy, right? And I'll pull this down a little bit. We'll be in business. Okay, so the first thing I want to show you is we have these files in this directory, and one is called Word. Let's see, where's Word at? We got words, Word text, and is Word even in here? It says open words text. Okay, so we look at words, it's 1.5 meg or 1.1 megabyte. Okay. Well, what does that entail? We'll find out as we traverse through this, right? But it's relatively small, 1.5 meg. And here we're just going to use the open function that uses, you can use open for a couple things, but primarily it's for files. Now, here's the thing. If your script and code is in the same directory as the file you're working with, you don't really have to give the absolute path. So you don't need the C:\\\/ whack, 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 / whatever directory it's in. If it's in the same directory, Python will do the heavy lifting for you. It'll check in your what at the moment is the default directory, see if this exists, and attempt to open it. Now, if we put another letter in here, I don't know, I'll just add some stuff, and I'll save this and I'll run it. You'll see that no such file or directory, so it can't find it. I didn't specify. And you see the default location that it looked in was the directory that the script is currently in. So that's important to understand. Now, a lot of people create a variable with your default full path, and that's fine, right? And then they just pop that variable in for the absolute path, and you can concatenate that with a string with the plus sign or however you need to, right? Real easy. But in this case, we're going to go ahead and just file in fin. It's pretty common. Hello. Open. We're going to open the file. We're going to print the file. No big deal, right? Save, hit F5. Now, you notice we got this input-output text, input-output wrapper, name, words, mode, default is read, because we didn't define what mode we wanted. And the encoding, that's beyond the scale of the class, but Sometimes you might have to change this, but for working with strings in this class, it's default's more than applicable. So now if we type fin over in here and hit enter, we just get that back. If we start running functions against fin, no length for an input-output wrapper. If we start doing like type of fin, we get that's the text input-output wrapper. So basically what open does is it clarifies some memory for your file to exist. Nothing more, nothing less. It allocated memory, it's open, but you did not instruct Python what you want to do next. It's in read mode, but we didn't read anything in. Now, when you open up Notepad or Word or a PDF viewer, they're all kind of different, but when you select the file and open it, it believes that you want to read it, because that's the core of those programs, interacting with those programs, right? And in this case, we're interacting with the programs, but we're interacting with them through a programming interface via Python. So the file is open, it's available, we just can't see anything yet. So that's pretty interesting. Let's go down here, we'll do some fun stuff. Get rid of this one. You're gonna see me go back and forth a couple times, and it's all right. All right, we'll get through this together. It'll be fun. What do I want to do here? This. There we go. So now we're gonna open words again, store it in fin again, set our counter. Then we're gonna say for each line in fin, add one to the counter, and once done, print out the count. Nothing too crazy. And you see, within that 1.1 megabyte file, there is 113,000 lines. Each line in Python, it's validated by that ends in a new hard return or a new line. So there is indeed 113,809 lines. This words file is every word from a dictionary. Not the definitions, nothing more than just the word itself, hard return, new line. So it's a lot of words, right? It's kind of cool. You notice we still can't display what they are, but it knew that there were hard returns for each object, for each line in my file. Tell me how many lines there are, count the lines, right? So that's kind of cool. Let's do this one. So the word, the input-output wrapper type of object, the class itself, the class of objects, has some other handy-dandy methods. Now, methods are nothing more than a function of a class. So when you call on the variable, you're calling on the object, and here we're calling on the method read line. So this is going to read the first line, print it out, second line, third line, fourth line, fifth line, sixth line. If you close the file and reopen it and then hit read line, you're going to read the first line again. It does not remember when you open and close the file where you left off, right? F5, and here we go. First line, second line, third line, fourth, fifth, sixth. Default print is a new line, so that's why you're getting that space between them. Remember, the end and print is a new line. So that's kind of cool. So you have read line. Is it handy? Well, we'll find out here in a second. So now we're going to do the same thing. Now we're going to strip some spots. Hit F5 again. And now what happened here? Well, you notice how this is just for demonstration purposes. I added a beginning space and an ending space on AA. I add the J's too for fun, just so I know just with my eye it starts. But in reality, when you read in the line, strip, there's a method called strip. Well, of course we know that from previous lessons, going back to lesson 5. So now you could take that line from read lines, strip it, and remove the leading and trailing spaces. Occasionally you want to do this when some databases hand you back files that are not optimal. They have spaces in the front and end, you just want to remove them. It's a quick way. You can create a function called strip leading spaces from first line. Throw this in there, be done with it, right? Normalizing data is 80% of a data scientist's job. because you get it from all different types of sources. Taking that data, making it usable and consistent, it takes time. So strip works. So a lot of the things we still remember, these are just strings, right? So a lot of the tools that we picked up along the way up till now still work. This one, same thing, open words. We're gonna go for each line. We're gonna strip each thing and print the word. We're gonna see how long this goes. Well, it's gonna go 113,000 lines. I'm gonna break it here, or attempt to. See, it doesn't like that. So this is bad. You don't often want to do that, read in and print every line, because sometimes maybe you didn't run count each new line, you don't know how long it is. Eventually, if it was a volume, a large substantial book, and this was a server and I had a bunch of stuff going on, potentially you can crash the server, fill the RAM up with nonsense and just end it. Not very handy. But what this teaches you is that you can control the document that you're working with, right? So now we're going to get into another file called Words2. Words2 is right here. It's a little bit smaller. It's only 1 kilobyte. I think it's like the first 15 or 20 words. Now we're going to use a new method called read lines. So you could write a function that says, open this file, check the lines. If the lines are larger than this, just grab the first 15 or 20, else grab the whole file. Like you could write logic on the size of your file before you even start tampering with it. That's helpful, right? So here we're going to read the lines, throw it into Words2 variable. We're going to print it. We're going to print the length, and then we're going to, you guessed it, use slicing and call the index of what's in indice 13. So now you see that when you open a document and use read lines and store it in a variable, it stores each line in a list, and each item is followed by a hard return. Pretty cool, pretty handy dandy for smaller documents or spreadsheets, things with a couple columns, not too many, right? Now remember, this is a text file we're working with. There's other types of files you could use with Python. JSON is a real heavily adopted. XML, things that are like Ansible files, like Yara, things like that. Things that are set up like key value pairs, right? And JSON is nothing more than a dictionary of dictionaries. It's a key value pair of key value pairs. And Python is a module called import JSON, and you can work with JSON files directly. Pretty prevalent nowadays. But let's check this out. Print Words2. So what we get the list. Print the length. It says it has 16 items in it. Well, the length of each line. So just say, 16 lines, right? Words, we call on 13. So we get AAS and 16, 15, 14, or what is it? 16, there's too many. 1, 2, 3, 4, 5. There we go. 18, 17, 16, not even. 17, 16. What is it? Yeah, it's 18, 17, 16. No, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. So there it is. But you'll get what you call in the 13th spot. There's 15 items. So handy. Super cool if you know what indice you're looking for, right? Well, if you're unsure, then you got this joker right here. This does the same thing. Now read will read the entire document. It's different from read lines. It's different from read line. So there's 3 methods here: read line, and read lines. You're going to say, well, why do I not just read the document? Well, it might be too big. You might want to read lines and then give it some parameters and read certain lines in. Constrain yourself, right? But it's up to you. But here we read this in, print the length of the words. We get 112. Now this is a bit different. We get the length of the words, it's 112. When we call on words, we use the slice from 3 to 20. Well, what's in words? it's one long consecutive list. So that gives you a different type of object back from read lines, where each line is its own object and indice. Here we have one gigantic line, and here we said, what, start at 3, go to 20. Start at 3, go to 20. That's it. So different methods give you different types of objects back. Pretty cool. Any questions so far relating to the classwork? There might be some, but we'll get to those. You're going to be like, oh, well, how often do we use this? Well, I use some form or fashion of open, and I'm going to show you another way how to do it too. It's called with. With is the newer, more accepted way. I'll just show you that now. A little different syntax than open. So with will let you do a couple different things, but when you use it with a file, you start with, it's kind of like import. It's kind of like from, import as, kind of like that type thing. So with your document, with open words in append mode as fin, and this is how you write to it by using write, but we'll get to that. This is kind of common in one line, and then dealing with the file in a subscript or just a script block underneath the with statement, because this is indeed a statement, and underneath it is you'll be a script block, and you notice it's tabbed over, just like a function or anything, or a function, like we define a function, or when you use a for loop or an if-else statement. This is the new common way. Like you'll see with a lot. With this open as fin, use fin. What you get with this is what we haven't talked about yet, is if I went to go use words or words too, and this is still open, it may cause a problem because I never closed it. When you use open, it's best practice to close your file. With, once you leave this script block and go back to left justified, it closes the file for you. So you gain that free close, one less line of code to write, right? Does that make sense to everybody? Now you can use open. I still, depending on how I'm feeling or what I'm thinking, I'll just use open, stuff it in a variable, then I'll close it. Most of the time I'll use with. It all depends on how I'm typing or what I'm doing or what mood I'm in. Honestly, I use them both interchangeably. Just keep that in mind, right? So I'll start working with a cool file. So we have this mbox text. It's kind of old, 6.6 meg, pretty big. 6.6 meg of strings. Think of this. If an entire dictionary could fit in 113,000 lines, how many lines of email could you have in 6.6 megs? More than human readable. Not going to be able to do it, right? So here we're going to open the file for each line in my file in. If the line starts with, here comes another method, which is from the string class. If it starts with from, print the line. That's pretty cool. Whoa, it's going to get out of hand quick, right? I stopped it, but you'll notice that the output, it's returned to us. It finds from in the line. It finds, but print has that default end with and all kinds of stuff, right? Can we clean it up? Of course we can. And now we're going to skip the white space. We're going to use strip before it. No problem. All that did was clean it up. Stop, please. This thing. It'll probably crash. I usually crash this once a class. Stop, stop, stop. And why does it? There we go. But this right here does the same thing, except it removes the line. So what does this do? For each line, strip it, and then if it starts with from, print the line. You could play around with this, move this in different places, and see if you'll get the same output, but obviously this worked, right? Now you're going to have skipping uninteresting lines. Well, let's talk about what's uninteresting. Well, here I'm going to open the same mailbox file. I'm going to do the same for each line of my file, strip it. Now I'm saying if not line starts with from, continue. Else print the line. It's going to do the same thing. Now, why does it do the same thing? Why won't you break? Oh, could you stop it, Shell? I guess I could just hit restart. There we go. Well, it's just reverse logic. That's all. We're using not here. And I'm saying if not starts with from, continue. So if it starts with any other word than from, just keep going and then print the line. Default, it's going to be from because everything else is just passed on by, right? Okay, it might be more expensive than looking for just from, but we can always compare that. So here we have another file called mailbox2, a little smaller, 1 kilobyte. We're going to set a counter for each line, strip the line. Now we're going to start looking for things. This is a domain. We're going to look for a domain. If line find this domain name equals -1, remember when find equals -1 means it didn't find it. So now we're saying if find equals -1, continue, else print the line. So if you find it, print the line, add 1 to the counter, right? I think I misspelled counter here. Yeah, I got a double C. So you notice that I shortened this document. We'll take a look at it. I'll open it. So here's the document itself. We're looking for find this domain. It is right here. It's in line 1. Didn't take long. Now it looked at all these and it didn't do anything. Right now, if we copy this line and just put it on the end, I'll hit save and close it. I'll do the same thing here, save F5. Now it prints out both lines and updates the counter too. So if you were hunting a needle in a haystack, did this potential threat actor from this domain send an email and you had the raw logs, pretty easy to find. Do you agree? Wouldn't be that difficult. Let's take a look at this now. Now, here's putting some of it together, right? Tagging skills we've learned through this entire class, gathered some input, enter the file name. They could either import the name that's in the same directory or the fully qualified domain name properly. We're going to say open that file name, store it in file in, set our counter, run through everything as normal, look for subjects. If line not starts with subject, else add 1 to the counter, and then give the user output. They were blank, count subject lines and blank file name. Okay, cool. So I'm going to just run this, hit F5. It's going to prompt me for the file name. I'm going to say mbox txt. I'm in the same directory. I'm going to hit enter. Now, 6.6 megs. By the time I hit enter, it already had after I let go of enter, my answer's already come on the screen. 1,797 subject lines and mbox text. That's pretty fast, pretty quick. Remember, new Python could do I think 10 million string checks a second now. So this was nothing. Super quick, super fast, super handy, right? Let's keep going. This one gets fun. And I kind of use this every day at work. When we have a large email spilling or something nonsense, a lot of times we'll get just raw logs from Exchange servers all over the planet. And, you got to flex your skills and write little code or save things I have saved already that I just open up and run on these files over and over. Always make copies of your original files that you're working against. Okay? Just remember that. So let's check this out. So what are we going to do here? So we're going to open up a new file, and I'm going to call it class output July. And for ease of use, let's start with the 0, right? So you notice in this directory, there's no such thing as 0 class output July. The file doesn't exist. When you use open and give it a file, doesn't really matter what mode. This is write mode. And then printf out, it'll create the file for us. Let me get rid of this. We'll just do this for now. So it'll create the file for us. Now watch down here in this bottom corner how fast this file is created. Okay, save it. Boop. It's actually done in Python before it appears in your GUI as an icon. Something important to know, right? You may need to put a pause in there, or maybe users won't see it. They have to refresh a screen to see it. All kinds of strange things happen when you're coding, right? Let's take a look at that again. So did I ever tell you that there's only 2 types of people in IT, like who work in IT? People who let people get the data, and then people who create data. That's it. And there's no other. Now, are the people who let them get to the data, the network engineers, also people who create data? Yes, totally. But if you have a job that entitles a computer and you never create any new data, then I wouldn't say you have much of a job, right? You're always working with some type of data, appending it, updating it, doing something. So the whole concept of IT is to allow people to get to their data, no matter where it's stored. And now we have complexity with clouds all over the planet and this and that, and all kinds of fun stuff, and APIs that could talk to different databases and different system subsets, AIs that you could program to do that with you with different neural networks under the hood, and under the neural networks you have different machine learning algorithms. Like it's complex, but it's kind of simple. And I mean that kind of not sarcastically, but truthfully. If you take each technology as it is, they're pretty simple. When you start adding them together, it gets more and more complex because certain things have to be in line in order for them to communicate. That's where troubleshooting comes into play, knowing your OSI model, knowing what types of protocols your entire suite uses. So if you're using something in SSH, you can't even log into the database. Well, SSH is probably broke. Your token's probably busted. Your certificate's bad. One of the 3, right? Maybe the network's down, but then everybody would be complaining, right? So you learn how to troubleshoot really fast when you hear what the problem is, and maybe not from the user, from a log. Because users will be like, I just can't get there. Now, users are getting more and more educated all the time. So maybe they'll be like, hey, man, something's wrong with my token. That'll help you out, potentially. But back to this, right? We're going to go ahead. I'm going to delete this file over here. Oh, I can't. Why can't I? Because we never closed it. Ain't that a son of a gun? Now I can delete it. That's what you get with the free close, right? Keep that in mind. So here we're going to go ahead and open this file again, which will create it. And then we're just going to throw a string into this variable, and we're going to use the write method, and we're going to write to our file. Very simple. Same thing. Another string. Variable, write it again, we'll close the file. And then I'll open it manually. We'll see what's happening, right? Control S, F5, boom, boom, done. It's already created. Open, close the file. It opened, it looked for the file, couldn't find it, created it, opened it, wrote your 2 lines and closed it faster than I could even type in Notepad or open up Word. So now that we double click this, you'll see that our data is there and it's awesome. Is anybody amazed at how fast this stuff is or how cool it is? Or am I just old and I'm just blown away by it all the time? Like, whoa, that's cool. Yeah, so now you
You
have
probably saw it when it was a lot slower.
yeah, oh yeah, it was painful. It was super painful. Now we're gonna do the same thing here. I'm gonna steal this name, copy, put it down here. I'm gonna paste it. I'm gonna change it to 1. Let's do this. So I'm gonna do the same thing here. So now we're gonna write to a new file. It does exist. I'm sending it a list, an array, right? A list of items, each with a new line. And I'm saying using the method of write lines to my file, or write lines to my file, and the payload is my list. Cool. I'm going to close it again. Boom, boom. It's right here, July 1. Ah, what happened there? Well, I didn't put new line after 2 or 3. No big deal. But now when we append this, we have to tell it new line or just keep writing to that one line. It's pretty weird, which we're going to get into now. Pretty cool. So the more you work with files, the more you work with the methods, you get used to little nuances of what types of objects you're working with. Like read gives you a list of all strings, and read lines gives you a list of each line. Those are big differences, right? That's what we have here. So now here we open the file that we created in read mode, and we just said for each line, print the line, and it added that, of course, because the print has a new line. Cool. Awesome. Now let's take a look at append. So you have a file, you want to add something to the end. What are you going to do to it? Well, you're going to apply to the end, append. So here we're going to pick on append1.text in append mode. And we're going to say line, I'm a lumberjack, going back to the Python or the Mighty Python stuff. I'm a lumberjack, I'm okay. Right, so print line, print right line, right, close. Okay, cool. So let's look at append1 now. It doesn't exist. Cool. Let's go ahead and save this, hit F5. Here's our new file. And it did exactly as designed. Awesome. Write lines takes an array or a list of items with hard return. Now you could also say for each line, you could write a for loop with write lines and get all crazy with it and have a bunch of fun with it. It's best to modify your data prior to writing with the hard return in it. But it really depends on what you're trying to do, honestly. But what other types of files are strings other than TXT files? Anybody know?
CSV.
Yep, CSV, comma separated value. Those are pretty. Those are just usually all strings. There's different types of CSV files, but the basic one is just strings. LOG files, log files, XML, JSON. A lot of these files, if they're not tampered with or thrown in through some type of cipher, they're just text. So that's a huge benefit because that means you could read them. They may be difficult to parse, but you could read them. Now, the cool thing about Python is all those different modules that for JSON, XML, and all that stuff. So you can manipulate those files as you need, right? And now we're going to just append mode. We're going to write one more line, and I'm okay. And then we're going to close it. And we're going to see where we're at. Oh, no, what did I do wrong here? Uh-oh, one extra little thing. Boom, it runs. It's done. Check our file. And we added an I'm okay to the end. There's also a module called logging in Python. When you create a complex program or a complex script, you might want to add some custom logging to it. It is worth the weekend or 2 weeks to learn. I don't think it's necessary off the bat to write small scripts because you could do things like just write out a log file, you literally create it and write it out. If you're not doing anything too complex. But once you cross that bridge, you get in a real complex script, you might want to learn logging, the module. It might save you some time. It might not. But that's the gist for files. Open, always follow with a close. With buys you that free close, so you can always use with. Let me show you with again. So we use with, let me see. I'll just go ahead, word text 2, save F5. And that's words 2. And you'll see here that we open this file in append mode. We use the write command or the write method, and we wrote new return. We used with because it would have just wrote it right here. But we did a new return and we used with, close the file. When we were done with the object, I automatically closed the file and I was able to open it in the GUI. So with is a little bit cleaner. Feel free to use it. Now, let's talk about, pickles are okay. I'd rather have you, pickles are cool. They're mentioned in your book. Deal with that in your book. DBMs, databases are pretty cool too. I'm not going to shortchange by not covering them here. I have the videos are in the class. You could watch the database and pickle videos. Say if you write a script that has to gather up machine data, system, serial number, last login, things like that. The DBM, you can have your script write a database file at the other end, and what it'll do is it'll make a backup and a file for you. So it's still plain text though. Now, if you use pickle, think of what pickling does in real life. It takes something, puts it into a jar with something else, and it becomes something different. Yes, it is still the original thing you put in there, but it's amplified. It's pickled, right? With vinegar, sugar, and water, right? So this pickling module, what it does is it allows you to serialize your data, which it does under the hood for you. And it I'm not going to say it compresses it, but it's very efficient in storing data. And it's a data format within Python. I haven't seen it anywhere else, only in Python. Sometimes if you write a pretty complex script that gathers data off an endpoint and it has to traverse a network, I would say an internal network only. I would not trust this going out over the internet. An internal network, pickle, what it does is it pickles your data so it's at least a little bit obfuscated. It's not encoded, it's not encrypted, it's not ciphered. It's literally obfuscated. It's like difficult to read. That's about it. Now they're cool because you can store a lot of data in a little tiny area, and it's really cheap on RAM. It's really fast to send over the wire. You gain a lot by using a pickle, but nowadays most networks are gig to desktop, and nobody really cares. That's the truth of the matter. Internally now, like when you look at internal networks, you're running at least a gig to the desktop now. Very rarely do you run even into 100 meg to desktop anymore. Does anybody work at a place where they're running only 100 meg to the desktop? I'd be surprised, right? It's all like gig wireless or Cat 6E or something, right? But yeah, there's a time and place for databases. I'm not going to waste all your time tonight going over them because we already have videos on them. Picklead is cool. There's a couple companies. There's a couple EDR platforms that in cybersecurity that leverage Pickle. I know Tanium does it under the hood a little bit, and a couple are, I think CrowdStrike does it. Anybody get the news about CrowdStrike this week? I don't know. That kind of bothers me, but oh well. One thing I want to tell you and show you is the OS module. This is insanely handy. So it's good to know about the OS and system modules when you work with files on a system. When you go ahead and import OS and do a dir on OS, you get certain things. You get like directory traversal, open, name, make directory, rename, all kinds of fun stuff, right? The thing to keep in mind is get current working directory. often handy in a script if you plan to write output or create new directories. You can get your current working directory and then go from there. So it's kind of like working in Bash or working in the Windows terminal, but you could do it through Python. Super handy, right? There's also another module called subprocess, which allows you to work directly with tools that are on the operating system that you're running your script on. A little bit more intermediate, not really in this class, but it's good to know about it. Now, OS has a method called path, and it has a sub method called absolute path. And you'll see that the absolute path of mailbox text is this C:\\\. There. Now, there's only one in the OS, but remember, in Python, a single backslash negates. It's an escape character. So you're escaping the meaning of the backslash, in essence, leaving just a backslash. And then that's the absolute path for the mbox text. This is super handy and dandy. And it also has a method called exists. Super handy if you're writing Boolean logic to test if something's there. So this said OS path exists mbox text, and I got false. What does that mean? Why did it fail? Anybody know? Let's take a look, right? My current working directory is an 8. Of course, I closed it, right? There's no mbox text file in here. That's why it's false. So let's create one, right? New text document, mbox. Now flip back. True. Cool. Think of that. If this file exists, append to it. Else, create the file and write to it. You can add a lot of twisted logic on if a path exists. Always check if a file exists before you write to it or create it. There's a problem. If you open a file and it doesn't exist, it creates it. If you write to a file directly, does it overwrite it? Yes. It does overwrite it. So be careful when you use write and append. Right? Write lines, write append. I believe write overwrites the entire thing unless you start with something, like a new line. Be gentle. Make mistakes with data you don't care about first. In other words, get to know the methods, right? Now, OS path and OS also has some cool other methods. Is directory true or false? That'll give you a Boolean back. Is file, list of directories, kind of like a dir or an ls. You do all kinds of fun stuff. Now, this is an example for using it with an error handling, right? Here you could try file open, mboxer, print open, fin, accept, something went wrong, right? Now you can add more logic to this with if the file exists, if the path exists, if the file exists, is directory, is file. You could add a lot more logic to this so you're not damaging any data. I just wanted to cover that in this lesson too because it's pretty important. Yeah, but and really group exercise for this week is pretty weak if you ask me. It's just like to create a file and write your output from the last lab we did. So I'm not going to go over. It's very cut and dry. It's pretty not that difficult. Plus, the video is already posted in the other channel on the results for it if you need it. Now, one thing I want to talk about before I open the floor for any questions is the lab. If you alter the World Series winners.txt file, you need to turn that in too, because I won't have your version. That's important. Dictionary is your best friend here. Find, in, find in dictionary, those are all your best friends for this lab. It's really not too bad, right? Knowing how to use that key and value, and depending on how you use your list. But the whole goal is here is, can you open this file? Can you close this file? Can you extrapolate the data you need from the file by using read or basically read line or read lines? Can you solve this problem without damaging the original file as well? Right? I think you can. Without everything we went over tonight, you should be able to, but it's going to take some time, a little trial and error, and you'll get there. Now, let me see. We're coming to the end here. Let me flip over to student mode. So tonight, I'll go ahead and make sure your final exam and your lab is available for everybody. What that'll entail, it's a 50 minutes, 50 questions, multiple choice. They may be different from what you've seen before, but it's open book. Not bad. And the lab is to create a trivia question a lab. So it's kind of like rock, paper, scissors, except with questions. Now, there is, when I make it available, next week we'll meet again. But when I make it available, you'll see that there's a PDF with already questions in it. Feel free to use them. Students have made Star Wars quizzes, the Harry Potter quizzes, quizzes of the galaxy, whatever. It's up to you. And it's flexing. Now, there is, in the directions, things you must have, right? It's not that bad. Header, footer, name properly. Use of a dictionary, list, or tuple, right? But the directions are there. You'll see custom functions, mainline logic, stuff like that, which you should be using anyway. And I'll make that available tonight. But yeah, that's it. It's been a pretty good haul so far. Next week, I'll go over some more advanced stuff just for fun. Things you should know, things that make living in Python easier at this level. And I'll talk about the final exam next week, but there'll be a video posted as well. Now, before I open up the floor for any questions, I'll go ahead and end the video.